Everyone's good? All right. So welcome, everyone. I mean, most of this crowd is our new faces, so I appreciate you guys for making the time today to make it out. So today we're going to talk about a topic that I really like, which is recommender system. So does anyone know what a recommender system is? Or thinks they can describe what it is? Yeah, what's that?
Like we get suggestions on YouTube.
Yep.
It's a recommender system.
Yep. So anything that comes in the form of a suggestion or some sort of kind of curated like recommendation to you. So here, haha, joke. Okay, so I don't know if any of you guys have actually heard of data science office hours. Yeah, okay. So that's something we do like every other Wednesday. Me and 5 other data scientists. We've been doing this for, I don't know, I think a couple months now, and it's been pretty successful. 3,700 subscribers, if you guys are interested. And then also, I mean, I assume if you're here, you're also a fan of Learn Teach Code. Hello, welcome. So a shout out to Ticketmaster. I mean, I think next month will be a year that we've been doing these meetups. So thank you to Ticketmaster for having us. If you guys are interested at all, they're always hiring, and they have some pretty neat projects that they're working on. I don't know if any of you guys were here for last month's meetup. Was anyone here when Sepida came and talked? Okay, yes, you were? Okay, so if you weren't here, she talked about bots and verified fans. It was actually very interesting. We recorded that session, so it's online if you guys are interested in looking at it. And if you guys are interested in the projects that they're working on, I know Paul is here, who's the manager of the data science team. And then Heather can answer any other questions that you guys have. So just want to say that.
Well, I only manage one data science team. There's a bunch of data science teams here. So
got it.
I manage the abuse prevention.
Okay. So if you guys want to learn more about the abuse prevention team, then you can talk to Paul. Otherwise, talk to Heather. Okay, so I post all of my slides online. So if you go to my GitHub, you can access them right now. Otherwise, you can feel free to add me on LinkedIn. I post there sometimes. Okay, so how many of you guys? Okay, so by the way, I gave a shortened version of this talk, not Friday? And I realized when I was up there that I'm not that funny. So I tried to, everyone else was so funny. And I'm like, oh my God, they incorporated memes. And usually I do. So I tried to incorporate a few more memes today. So, okay, so how many of us have felt like this before? Yeah, like every time you go onto Netflix? Okay, so what's nice is that recommendations are pretty much everywhere, right? You open up Netflix, and you're like, okay, well, based on these movies you've watched, here's some other movies you might be interested in. LinkedIn, based off of the things that your education, your experience, suggests other companies that you might be interested in working at. YouTube, based off of your viewing history, will recommend other videos that you might be interested in. And Google, I mean, that's great, right? Like you're looking up stuff, and they'll curate other questions that you might be curious about. And then Amazon as well. I mean, the list goes on. Facebook will recommend other people that you might be interested. LinkedIn will also suggest people. So they're pretty much everywhere. So why is it necessary? So there's this idea of information overload, right? So when you think about prior to the internet, how products and services were kind of presented to you, what did you do? Advertising on TV. Advertising on TV. Okay, good. That was one way that they would, and then there's like a limited amount of advertising hours that they can deliver things to you. Or you would go to your local Blockbuster and or your local Walmart or wherever the stores are, right? And shelf space is expensive. So they have to really think about what types of products and services they're going to put on their shelves in order to maximize their revenue at the end of the day. So they can't just have everything out there, right? So they have to really think through what products and services they're going to put out there. So that's what we would call hits, right? So they're going to try and put the best products out there for you to buy. Does anyone know what that diagram is about? What's that called?
How popular products are.
Yeah, so this is called the long tail.
Long tail.
Yeah.
So long tail means they're not necessarily very popular, but there are many products.
Exactly.
And you want to match those with a user, but not the majority of users. You need to match with the right user.
Exactly. So here what it's saying is that this is essentially a diagram of all, let's say this is the universe of products, and this is their popularity. So there's going to be very few products that are very, very popular, but then a lot of products that aren't so popular but are still relevant, right? So until we're able to essentially do this, right, near zero cost dissemination, which is what the internet allowed us to do, we can now pay very little for hosting all of our products and services online and allow all of these long-tail niche content to be available everywhere, right? But this is a lot of products and services. So what we want, ideally, is to filter them down to only the ones that matter to the user, right? So to kind of curate this list of suggestions. So types of recommendations that exist are, let's say someone went through and maybe staff went in and made a list of favorites, but that's kind of like a one-size-fits-all type of recommendation, right? Or simple aggregates. You can say, okay, well, the majority of people liked these things, and you can present those. The ones that we're most interested in are recommendations that are tailored to users, which is what you find that Amazon, Netflix, Pandora, the list goes on, is doing.
Or like Facebook recommends friends.
Facebook recommends people. So, and again, the list goes on. Like everyone is basically trying to find a way to filter out these products and services and deliver a personalized experience. The reason why this is important is because of this, right? Like, we know that all these products and services exist, or actually maybe we don't even know that they exist. And it's kind of, the way I was thinking about it on the drive here is like it's a matching problem, right? The business has an incentive to get you to buy their product. And the user has an incentive to, this problem of wanting to know about things. And usually it's like, oh, I'm searching for this and I know what I want. But what if you don't know what you want? And this product exists, and unless it's delivered to you or shown to you, then you wouldn't know about it, which is what this long tail is showing, right? So are we okay so far? Okay. So there's two ways that I'm going to cover in terms of approaching this user recommendation problem. One of them is collaborative filtering. The other one is content-based filtering. Has anyone heard of either of these? Yeah? Yes. Okay, some people. So collaborative filtering. What do we think collaborative filtering
We match users based on similar features, and then users that have similar features. That's same.
Yep. So collaborative filtering is like, think of a collaboration, right? So we're collaborating together to recommend things to one another. So collaborative filtering. So this is a terrible diagram that I made. Okay. But it's like based off of someone else's diagram, but I didn't like that the guy was sitting in a bath. So I remade it. All right. So the idea here is that you're recommending items to a customer, this guy, let's say, that was rated highly by some other user. So you notice how they have similar likes and dislikes, right? So they both like pizza and salad, but this guy's tried this new product, also like this product and rated it. So assuming that they are kind of similar in this way, then we might want to recommend this item to him. Okay, so I'm gonna hopefully my aim is by the end of today you have a general understanding and some of the details of how to approach this. So there's a few steps here. So one is you want to find the neighborhood of users that are similar to this person, right? Then you want to make a prediction and then hopefully make some smart business decision as a result. So came up with a cheesy example. So let's go to the movies. Haha. All right, so I need you guys' energy. Okay, like, it seems so dead in this room right now, and it's not acceptable. So I've added memes to make you guys laugh a little bit. Okay, so let's say these are our group of friends, and this is David right here at the end. And David is the user I'm concerned about because I am an advertiser, and I am promoting the movie Jumanji. Has anyone here watched Jumanji? No? Did you like it? Huh?
The old one.
The old one, okay.
Good.
Did you like the new one?
Yeah.
Okay. Did anyone else watch Jumanji? Yeah, did you like it?
That's good.
Yeah, I thought it was pretty good. You watched it?
The old one.
The old one?
The original.
All right. Okay, so let's assume that I'm the advertiser and I have information on you guys. And you guys have told me from prior movies that you've watched what you liked and which ones you liked and which ones you didn't like based on a scale from 1 to 5. So 1 being you absolutely hated it and 5 being that you absolutely loved it. So this is my universe, very small universe of users. And now I have this new user. His name is David, and he's given me a few hints on kind of what he likes and dislikes. But I need to make a prediction on whether he's going to like or dislike Jumanji. So I need to know if I should advertise to him or not. So notice on the right-hand side, I have the similarity score. So that's what I need to start filling in. So in order to find the similar users, I'm going to break this step down. So I want to first define a measure of similarity. Then I want to calculate the similarity between David and every other user in my universe. And then I want to rank and choose the top n. So notice this is a user-based collaborative filtering technique because I'm looking at similar users. Okay, so defining a measure of similarity. Anyone have any thoughts on how we could do this?
Assign a
Okay.
value to that. By the light. Just like that.
Okay, like genre?
Right.
Okay.
If somebody like most of the movies like action, it's like horror.
Okay, that's one way. Hey, all right. Any other ideas of how we could, assuming that we have? Sorry, yeah. So assuming that this is our universe of users, and this is the information we have. We have information on each user and how much they liked or disliked a movie. Well, first of all, can I get a raise of hands? Anyone in here work in data science? Okay, so some of us. Okay, so of you guys who raise your hands, how would you define a measure of similarity?
Cosine.
Okay, yeah, cosine. So that's one way, right? So, well, first of all, yay, math. Okay. No, we don't find this funny? Okay, I was cracking up. Okay, so cosine similarity. So cosine similarity is essentially taking two vectors and finding the angle based on the angle between those vectors, giving us a value. So the closer to 1 means the more similar. So the higher the cosine of theta, the higher the similarity between the two. There's also Pearson correlation, which is just a normalized cosine similarity or a modified cosine similarity that allows us, in this case, to take into account the different ways that users score or rate movies, right? So someone could be a really harsh rater and someone could be a really easy rater. So to take that into account, we can normalize by the mean of each of the users and then then calculate the similarity. So that's the main difference between these two. So assuming we did that, right? So now we've calculated the similarity scores. Here I've calculated the Pearson correlation. And I've ranked these guys. So these are my 4 candidates. And I need to find the one that's closest to David. So assuming those are my cosine similarities, who are going to be the closest to David? Louder. John and Eric, right? Sorry, I teach a class and I'm very dorky and I try and get people to actually interact with me in whatever means possible. Okay, so John and Eric have the closest similarity to David. So let's say here I've chosen n to be 2. So my neighborhood is very small, but in the case that I have a very large set of users, maybe I want to expand that maybe to be a little bigger. But in this case, John and Eric are my neighborhood of users for David. So question to you guys, how can we use them to make a prediction about David? Yeah, average. So the simplest way is to average out their scores. So we could take 5 plus 3 divided by 2, 4, boom. Another way, if there was high variance, we could take the weighted average, and I mean in this case, because our values are so close, really the values aren't that different. So yay, we predict that David is going to like Jumanji, and we serve him with an ad. Boom. All right. So this is making a smart business decision. So the advantages of collaborative filtering is that really when we were doing this, we didn't need to go in and know anything about the items, right? We didn't say, oh, this movie is this or this movie is that. We just basically looked at the users' ratings, and we used that to come up with our recommendation. So we didn't have to go into the contents of each item in order to make the recommendation.
You wouldn't use the genre of the movie?
Not in this case, but we'll get to a case where we would. And then secondly, we have more diversified recommendations. So a user is going to like many different things, maybe across different genres. And so because of the fact that we're using user inputs and not content-based, which is when we'll talk about genre and stuff, you can end up at more diversified recommendations for the users. Some disadvantages is that because we're waiting for users to actually give us a rating, we might end up having a bias towards only the popular products because they're the ones that are being rated more. And so those are the ones that have more kind of ability to be actually recommended to other users. The other disadvantage is that you actually need to collect information on other users. And ties into number 3 is that the best recommendations will come off of a very large user space, right? Not when you have a very small one. And then you have this cold start problem. Does anyone know? Yep.
Sorry, just question. Is this presentation going to be sent out afterwards?
Yep.
Okay.
Yeah, it's already on. It's already hosted online if you want access to it.
Awesome.
And I'll bring up the link in a second after I'm done.
I found it on your GitHub.
Yep, it's on my GitHub, and you could grab the link from her if you want to see it.
Frantically trying to.
Okay. No, it's all online. Yeah. The last disadvantage here is the cold start problem. Does anyone know what the cold start problem is? Yeah.
It's like if there's a new movie out there but no one has seen, how can you like calculate all those things?
Yep. Exactly. So there's the cold start for new items and the cold start for new users. So for a new item, because it's new to your collection, it hasn't been rated before, you're not going to have any information on it. And then you'll also have a cold start for a new user because you need to know kind of their likes and dislikes in order to match them against other users. So there's ways that we get around this. So if you've ever gone on to, I made a Pinterest the other day. And the first thing they do in order to make a board for you is what? Yeah, so they force you into telling them things that you like in order to curate a board that you might actually enjoy looking at. Another way that they can get around this is by giving you the system-wide average, so recommendations for the average user, or if they happen to know your demographic, they can give you a system-wide average for that particular demographic. So there's ways to get around it, but it is something to think about. All right, so content-based filtering. Anyone have any thoughts on this? Yeah.
It's like context-based, so it's like genre or.
Yep. Welcome.
Actual description.
Yep. So exactly right. So now instead of looking at user similarity, now we're looking at the actual content of the item, right? So in the case of, which one did you mention? In the case of like articles, it could be the words in the article. In the case of a movie, it could be everything that goes into the movie, the actors, the genre, the words that make up the description of the movie, and you could go on. So content-based filtering is essentially finding, so based off of one item, how can you find similar items based on the actual content of that item? So, few steps here. So the first step is to define the item profile. So that's what we were just talking about. Then you need a user profile, something about the user that tells you some things that they like or dislike. Then you can calculate the similarity and rank and recommend. So here in this diagram, I don't know why I chose Coke, but hey, he likes Coca-Cola, he likes soda. So like maybe another type of soda. All right, then we can recommend it to him. So it's based purely off of the item and not of other users. So here, the step one, so define the item profile. So like we were saying, for movies, let's say Black Panther is out. Still haven't watched it, but
Shame on you.
I'm gonna watch it on Sunday. I'll watch it tomorrow. So okay, so say this is our profile, right? Maybe things like the genre, the language, the overview, the actors, maybe the user score, things like that could be incorporated as features into our item profiles. For articles, maybe it's the topics in the articles or the words in the articles. I mean, anything that provides us with some understanding of the context of that item. So, assuming we have all this text, right, that describes our items, how do we translate that into a recommendation? I'm looking at you because you said but
oh well, I mean, so I guess just talking from the top of my head, right? If you're able to define the relationships between certain things, then I guess you would just like, I don't know, sum up all of the recommendation. I don't know, ones. I think it'd be like a tree or something like that. You would have to like do.
Okay.
Yeah.
Okay. Sort of. Sort of. Yeah.
Well, I was just gonna say generally that you look for an item that is similar. So similarity between the two movies or two products.
Okay, so how would you do that? Like assuming a machine didn't exist, you would do it by basically what, like reading the description and saying, okay, or like, hey, this is a similar genre, right? Like you would read whatever description of the item, or you'd have an image that would help you out, right? Like, oh, this is a pen. Oh, that's another pen. These are similar. But like, assuming that you don't have that, now you have to rely on a machine to do that for you. Yeah. How do you get around that?
Did I talk to anybody?
Yes. Yes. What were you gonna say?
I would extract some features out of the description of the user profile and the items that I have, and try to weight it somehow. Like try to weight the feature vectors and compare it from the items with the user profile. Exactly.
Okay, so you've described essentially what we're gonna do. So, okay, so assuming that we have all this text, I mean, I should have done this first, but like, oh my God, like what? Like, okay, what do we do with that? Okay, so TFIDF. Has anyone heard of TFIDF? Yes, some of us? Okay, so I did a prior meetup just on TFIDF.
Oh, wow. So
TFIDF is term frequency inverse document frequency, which is kind of what you were describing. For those of you who are not familiar with TFIDF, it's a way of creating a word embedding based off of a corpus. So in our case, our corpus would be, I don't know, let's just say articles, right? So we want to find similarity between articles. And we have this corpus of articles, and each article is representing a document. So in that document, now I want to do the following. I want to weight a word. So this is the intuition. If a word appears frequently in a document, then it's important, right? So that's the term frequency part of this. Then you're going to weight it down depending on how many times it appears in every other document. So if a word appears in many documents, then give it a lower score. So that's the IDF part. So those multiplied will give you a weighting for a word in a particular document. So an intuitive way, some example of a way to think about this is the word the, right? So the might appear a lot in one document, but a lot in every other document. So those two numbers should kind of create a weighting that's low enough that it's not unique to that document. Versus a document that's like about machine learning. Okay, great. So if it appears like a few times in one document and not in many of the others, then that must have a higher weighting. So the way that we do this is by creating vectors out of each document. So each document now is a vector in term space, and now we're dealing with vectors again. And when we're dealing with vectors, we can look at the cosine between the vectors to measure the similarity of them. Is that okay? So here in 2D, you see here's a document about astronomy, about movie stars, about mammals. So like if you did a cosine between them, you would find their similarity. And then this is kind of more realistic. You're in n-dimensional space, right? And so we rely. Sorry?
Are the axes the features or are the axes?
The axes are the features, yeah. Yeah.
How would you, what's the projection of the vector on these axes? How do you get the vector?
So I'll do an example, and it should make more sense. So, so this is what your output of a term frequency, a TFIDF matrix looks like. So each of these is representing a document, and each of these are representing a unique word across all of the documents. So T1 to TT should be unique. So they're unique words, and then each IJ is representing the weighting of that term in that document. So is this okay? Yeah.
The weighting means the frequency.
The weighting is a combination of the term frequency and the inverse document frequency.
Yeah, was basically my question. Like the weighting is the occurrence of the term in that specific documents divided by the occurrence in all documents?
Not divide. So I'm going to go into that in 1 second. Okay. Yeah. So to understand this a little more mathematically, so the first part is the term frequency, right? So it's measuring how frequent a word is in one document. So there's several ways that you can calculate it. So it could be binary, either it appears or it doesn't appear. Or you can look at the raw count of how many times it appeared in that document. And then more frequently, you'll try and do some normalization. So the term frequency is actually going to be the frequency of the word in that document divided by the total number of words in that document. Or you can do a log normalization, 1 plus log of the frequency of that term in that document. So for those of you who appreciate the math, here it is. For those of you who don't, all right, we'll do an example in a second. Then you have the inverse document frequency, which is the weighting of how many times that word appears across all of the documents, which is calculated most frequently something like this. Log of the total number of documents divided by the number of times that word appears in that document. So let's do a quick example. All right, putting it all together, this is what we're looking at. So each W, I, J, or IK is multiplicative of the term frequency and then the inverse document frequency. Okay? So if we're looking at an example, let's say you have a 100-word log with the word JavaScript 5 times. Then the term frequency would be what? Okay. So it would be 5 divided by 100, right? So the term frequency is the number of times that word appears in that document divided by the total number of words in that document. So 5%. Then the next part, assume you have an entire collection of blogs that has 10,000 documents and the word JavaScript appears at least once in 100 of these. Then the inverse document frequency would look like what? You don't have to give me the number, but give me what the calculation is.
Like log
A
1,000.
log of 10, which is
Okay. So, exactly. So log of 10,000 divided by 100. And then to calculate the TFIDF, we just do what?
Multiply those two together.
Okay, so easy enough?
Yeah, one.
Okay, so this is essentially what you're doing for every word across every document. So woohoo! All done. Good try. Not almost there. We're almost there. So the next thing we have to do. So are we okay there to wrap up on that? Okay. So the next thing we have to do is define the user profile. So there's two ways that we can do that, which we also needed it from above as well. So explicit or implicit. So explicit, you just ask for, well, you don't just ask, but you ask for users to actually rate things that they've watched or things that they've tried, or somehow get users to give you feedback on something, which here is like it's only a fraction of users who are actually going to engage and give you ratings. So it's harder to scale explicit user ratings. But it is a more accurate way of approaching this problem. The other way is implicitly. So by observing a user's behavior. So you can look at the way that they engage with things, which is probably the way that YouTube does it, right? So they look at how you're completing videos, and that's an implicit way of them measuring your your likes and dislikes, or whether you purchase something that's telling you, hey, I like this product, so give me more like it. So this one is a lot easier to scale because you're not asking the user to do anything, and you can collect it with little to no cost. But it's hard to collect low-rated products, right? So because these are all positive engagements, so they're telling me that the user likes this, but how would you measure a low-rated products, right? So these are issues. So again, we're going to have to calculate similarity. So we have the cosine similarity that we're going to use. And in this case, now we're looking at the item profile and the user profile and trying to match those. All right, so the advantages here is that we don't need data on other users. So it's purely content-based, based off that item and similar items. Then you're able to recommend users with unique tastes. So what if I like things that are very, very specific and niche? Then I'll always be given something very similar. But then also it's harder for me to get out of that, right? So if I'm expressing interest in something that is very niche, then maybe I'll only get recommended those things, and it's harder to get recommended something outside of that. That'll be a disadvantage, but connecting the two. And then you're able to recommend new and unpopular items. So remember the long tail, right? So unpopular items, maybe other people don't know about them, but you're able to recommend them here because you're not relying on people expressing interest or liking towards something. And then you can give explanations because you have the features that created the similarity between the items. So the disadvantages is finding the features in order to create this similarity is hard, right? Think about images, movies, music. And Another disadvantage is over specialization. So because you're kind of narrowed down into this kind of narrow space of things that you can get recommended based off of things that you engage with. Mm-hmm. And then the cold start for new users. So if I'm a new user, again, I'm going to have this problem. If I haven't expressed interest in anything, then how are they going to recommend something to me? All right, so I have an example to show you guys. How are we doing so far?
We're doing great.
Oh, no. Oh, okay, good. I'm like, I was worried that they weren't seeing anything. Let's see, let's do this. So I went through and I don't know if anyone tried looking into recommendation systems. The resources are not that great. Even this article, I think, is a great first a great great article to use. I think it has an example that I basically translated into Python that we can walk through. So if you have Jupyter notebooks, you can, if you clone my repo, you can walk through this with me. If not, we'll just do this and then we can go over that after. So, so I'm basing this this example off of the example they showed there, but it's also a to be more specific, it's based off what we just learned, which is content-based recommendation systems. So, are we okay with Python? Yes. Okay. Yeah. Okay. So pandas, NumPy. Then the next thing I'm going to do is build an item profile. So my item profile is essentially this very short list of articles. And so let me just show you what that looks like. So here I have a data frame, and each row is representing an article. And then the 1 or 0 is representing the topics in that article. So if big data appears in the first article, then it has the 1. Then R, so R does not appear in the second article. Python does. Learning Paths does, and then etc. So those are all of my articles and the topics that appear. So a note here is since we have a binary matrix, if I use 1 plus log of the term frequency, then essentially my term frequency matrix looks exactly like this. So if I had applied a term frequency, this is exactly what I would result in. So then what I'm going to do next is normalize based off of the number of topics in each article. So, so it'll look something like this. So the total attributes for the first article is 3 because 3 topics appear in that article. And then 3 for the next 2, okay, etc. So the next thing I want to do is normalize it. So what I'm doing is I'm going through and dividing by the square root of the number of attributes in each article. So this is now representing my term frequency normalized matrix. Are we okay here? All right, nothing fancy. And then the next thing I do is get my document frequency in order to calculate my inverse document. So the IDF is just the log base 10 of the total number of articles divided by the document frequency. So it's just taking 6 divided by 2 and then taking the log base 10 of that. All right, so that's my inverse document frequency. So those together represent my TFIDF matrix. I haven't turned it into a matrix, but I'm going to do the dot product later. So the next thing I'm going to do is ask for a user input. So I'm going to say, well, did you like article 1? Okay, I liked article 1. Did you like article 2? Okay, maybe no. So I'm representing my likes and dislikes in terms of 1s and 0s and -1. So 1 means I liked it, -1 means I didn't, 0 means that maybe I didn't even read it. So 0, 0, 0, and then 1. So this becomes user input, and so to create the user profile, what I'm going to do is take the articles, the dot product between the article, each article and the user profile. So essentially, this is my the value that represents how much I like article 1. And then this article 2, 3, 4, 5. 1, 2, 3, 4, 6. I'm taking.
You mean how much you liked it?
Wait 1 second. 1, 2. Okay, sorry. 1, 2, 3, 4. I'm taking each of these transposed and multiplying it, by the user. Okay, well, so let's just go here. So essentially what I've done is created this user profile. which is just the dot product between this guy and that. So I'm taking each of these columns and taking the dot product with the user input to get the user profile. So based off of each of these, okay. The dot product between this user profile and, all right, let's just go back here. This is the same. Okay, so now based off of that, what I can do is look at Article 4, let's say, because he hasn't read Article 4. Wait. So he hasn't read Article 4, right? So all of these zeros are saying he hasn't read 3, 4, or 5. So maybe I want to make a prediction of whether he will like Article 4. So I can grab that that row, that vector, and I can essentially take the sum product, which is just it's like taking the first element in each vector and multiplying it and then summing them. And if that value of this vector, the user profile, is less than 0, then I wouldn't recommend it to him. So, okay, so I get don't recommend. And if I look at this a little deeper, I see that for articles that deal with R, he didn't like it initially, right? So this is saying I like articles that deal with big data. I don't like articles that deal with R. I don't have any user input for Python machine learning, but then I do for Article 6. So based off of his likes and dislikes, we see that this article has a lot to do with R, and because of that, he doesn't like it because he didn't, right? He didn't like Article 1. Oh, sorry, Article 2, which is this one, which deals with R, and because this is the only other article that deals with R, he just happens to not like it. Okay, so are we okay? Sorry, I feel like maybe I confused you guys. But essentially what this is doing is taking the dot product between the term frequency, inverse document frequency matrix, and each row in there, and the user profile to determine whether or not he would like or dislike. All right, well, that's all I had prepared.